Hello. Hi, friends. How's everybody doing? Yeah, at the end of the conference, that's a big deal. That's a big deal. It's a big deal. That's awesome. Well, let me first just start by saying thank you to Jump and this awesome set of folks that have helped me get here. Thank you to Anne and Janice and Diana and Hannah and Haley who have helped me really shine, or I hope shine. It's not their fault if I don't, though. But thank you for that. And I have heard that you've had a lovely summit, and that there's been a lot of information sharing and innovation and all kinds of awesome stuff. So I'm really excited for you about that. And I hope to add a seed of an idea in this conversation this morning. So really looking forward to sharing with you my story, which ultimately began with a love affair of the night sky. It's that simple. I think the sky is beautiful. And let me just share a spoiler. There are 0 slides. 0 slides. You just have to hang out with me. That's what we're doing. That's what we're doing. As a recovering astrophysicist, I know that is revolutionary for these kinds of fields, but we're reimagining today. We're trying something different. We're using a different set of mental skills in this conversation. So I want to tell you a story, but I really, having now been in public service, I'm going to start with the bottom line up front. The bottom line, if you don't hear anything else that I say during this time, is a request that you do something. Just do something. Do something. Do it right now. Do it right now. And then repeat it over and over again. What do I mean by that? I mean that the things that brought us here are very well-resourced, very well-educated, well-positioned folks. Those pathways are changing now. And the way you got in may not be available in exactly the same way to the folks behind you who are the future well-resourced, well-trained, well-positioned people. And so my question or challenge to you is that you, specifically you, each individual person, I love this room because I can actually look you in the eye. You do something. And there are a wide variety of things you can do. We can talk about that. I'm going to tell you some of the things that I've done. May or may not want to do the same thing. I have notes. But please do something. And if you've done something, keep going. Keep going. Do some more. I'll say this again at the end, but the future is fiction until we build it. And I know that there's a lot circulating around for all of us right now that makes it seem maybe like all the answers are had and they're all bad answers. But as you've seen over this summit, and as we know, that's actually not true. So please co-construct the future with me. Do something, anything. I'll give you some hints about what I did, and we'll go from there. Okay, so this love affair business. How did I get started? I had the awesome privilege of living in a place where I could see the sky. I want you to know that is a huge privilege, because the night sky is devastatingly beautiful. There are so many mysteries and questions and thoughts you can have, and there's really nothing like it. There's nothing like it. If you've experienced a dark sky, I see some nodding heads, you know what I'm talking about, but it's like a transcendent experience. And I didn't know it as a privilege at the time, but I had the privilege of seeing it. And I remember as a little girl being like, I need to understand more about what this is, how to get here, what's happening, how should I engage with it. That is how it all started. What is the sky? What are those twinkly things? I also, you'll find out, have lots of questions. I've had questions my whole life. Questions. Why is the sky blue? Why do leaves turn colors in the winter? Why do stars twinkle? And my mom, very early on, decided it would be a good idea if I had a library card. She decided that was the best place for me to go in order to really get at all these things. It's the voracious curiosity in my mind. And that was one of the kindest things she ever did for me, because it really did open up this opportunity to literally ask any question I want, understand the Dewey Decimal System, find books on my own, and really get into it. So I will say that I'll come back to my mom in a minute, but the sense of like the world as wonder and something that can be answered and asked about was really important to my upbringing and journey. So my sister and I would go to the library basically after school roughly every day. We were very well known there. We were celebrities. It's fine. It's fine. And we loved it. And about 12 years old, I decided, you know what? Enough of this foolishness. I need to figure out what I'm going to be when I grow up. This is very serious business, 12-year-old. And I knew that I love the night sky, and so I knew that it had to be something in science and technology, because I understood, at least at that point, that like if you're learning about the sky, there's something science-y in it. So I found this little red book at the library, which I actually am still trying to find in real life. Like I actually want to find that edition of the book. But anyways, a little red book, and it was gold embossed, and it was like careers in science and technology. For a 12-year-old, that's like that's it. Like, here's my question. Here's the book with the answer. So I opened this book. I didn't turn very long, and I saw the page that said astrophysics. It's very early in the book. And I read the description, and it said, like, someone who studies the night sky and, like, tries to understand physical phenomena about, and I was like, whoa, whoa, whoa. Whoa. Sorry. Did you just say there's a job to stare at the sky? I just want to make sure. I'm 12, so I'm not sure, but like, is that what you said? And it was indeed true that you could have this job. And I tell you what, like, I have never felt so seen in a random library book than to know that, like, there was this thing that, like, I naively was just like, oh, it's beautiful, and also then this, like, real-life adult thing that you could do to follow it, right? Also, as a 12-year-old, the word astrophysics is a cool word. Like, just like, legitimately just as a 12-year-old. I don't know if y'all know 12-year-olds, but like, it's multisyllabic, it's sort of rhythmic, you know, and so I also got like a huge kick out of just saying the word. These things are important though, because I remember coming home from the library and be like, Ma, I finally figured out what I'm gonna be when I grow up. And she's like, oh great, yeah, what are you gonna be? I was like, an astrophysicist. And she was like, great. Then let's do it. Let's get there. Let's, figure out what we're going to do, blah, blah, blah. I will just foreshadow my story and say that when I finally graduated with my PhD in astrophysics, it was only then that my mom, like, whispered to me, I had no idea what that was when you said it, but you were excited, so I was excited, and so here we are, which was one of the most hysterical things that happened to me at my graduation. But her unbridled, like, belief in me that I could do this thing, even if she didn't know what it was, that she could help me figure out, okay, well, you found it at the library, let's keep going to the library, let's keep asking questions, et cetera, et cetera. So there was a very early sort of like point where, for me, it was my mom, another great privilege to have a mom and a family who believed in me, because while we didn't grow up with the richest of resources, we also didn't grow up on the poorest of resources, but it was also not a given that I was going to be an astrophysicist. You know what I mean? Like, just normal, just regular, easy peasy. But that notion of a meaningful other, that's what the literature calls it, meaningful other, like a person who believes in you just because, and they believe in your visions and your goals just because, right? Like, that person is important, and I think what happens sometimes is that that person is so embedded in experience that we forget that we've all had that person or people in our life. We've had meaningful others. I'm like, no, that's a good idea. You should do that. There's probably been a lot of that in this room as well, right? This week or this last few days, I have this idea for this project. I think I want to do this thing. Let's do it, right? Like, that's a meaningful other, and it's actually really critical to success over time. Okay, so I'm a 12-ish year old, and I decide that I'm going to do this work in astrophysics. And it took me to science fairs, it took me to research talks, it took me all kinds of places, but ultimately it took me to college at Norfolk State University, which is a historically black college university in Norfolk, Virginia. I went to Norfolk State for many reasons. One of them, most importantly, was because it gave me a full ride. Money matters. But it actually ultimately ended up being another one of the critical decisions in my life, because it's a mission-driven institution, and they cared a ton about my success holistically. That turns out to be incredibly important as I move through this story. So I got a bachelor's degree in physics. It was great. They did not have astrophysics. But as a very astute person, I was like, well, physics is at the end of the word. So I can't be that far off. And it turns out it was a wonderful preparation. Having a physics degree has been amazing and like really the groundwork for all the things. I also want to sort of just stop here and say that like institutionally or structurally, having institutions that can take students and learners at any stage is a really critical component of what reimagining a science, technology, and innovation landscape of the future will be. We just all won't be able to go to super exclusive places. We may not all even want to go to super exclusive places. So having lots of on-ramps and inroads is really important. So I got my bachelor's degree. I loved it. It was great. I was on my way. I had 1 degree. I was going, and I felt like I was on the right track. And life threw life at me. Life be lifin' is what I like to say. And so I knew that I wanted to be an astrophysicist, but at the moment I couldn't move straight into the pathway. And so I will spare you the details, but I had folks that were helpful to me in like going out of my field and then coming back in. There, we did it. We talked about that. We've moved on. I ended up at a program called the Fisk Vanderbilt Master's PhD program. I mention that program in particular because it was a first-in-class experiment about how to get students from HBCUs and other minority-serving institutions into R1 institutions to finish their degrees. Because, fun fact, many mission-driven institutions aren't PhD-granting institutions. So you sort of run into an edge of where you can get your degree at particular institutions. So the experiment was, can you just basically match institutions? So Fisk and Vanderbilt are both in Nashville. They're like a mile apart. It's a really good experiment on whether or not we could do this. So I was in their first class last year, obviously. And it was an incredible experience because I got the sort of familiarity of an HBCU. Fisk is also an HBCU. And the sort of like rigor and that's not a fair statement. They're both rigorous. The sort of like technical training in astronomy is actually what I'm trying to say. They had an astronomy program at Vanderbilt at the same time. It was wonderful. It's where I really knew that astrophysics was for me, and it's where I started to disambiguate the kind of astrophysics I want to do. So I, as John mentioned, study supermassive black holes called blazars. We'll get to that in a second. But my research advisor studied protostars, which is also really cool. They both have accretion disk. They both bring on material. It's really cool. Black holes do it better, but it's fine. Like, if you like stars and planets, like, I'm not mad. Supermassive black holes are better. Anyway, so he did, as a mentor, one of the most difficult things at the time, but what I realize now, one of the most generous things he could have done. He said, okay, listen, the kind of research you want to do here, we don't have. But you're really good at it. So while this is a bridge program and you're supposed to bridge to Vandy, we'd like you to apply to a number of institutions that also have the field you want to study. And I was like, great, because I was very confident these schools were not going to let me in. So I was like, I'm happy to copy and paste my application and send it to wherever you want. So I sent off my application to a variety of institutions, and ultimately, the one that I wanted to go to that had the exact research that I wanted to do accepted me. So I said, okay, that's great, you know, it's cool. So I like casually walked into his office. Anyone who's been a recent student knows how you casually walk into your advisor's office. Hey, so I got accepted into this program, but you know, like, right, I need to fill in my like transfer forms for Vandy, et cetera, et cetera. And he was like, cute, you got to pack your bags, you're leaving. I was like, whoa, 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 whoa. Leaving where? This is home. Scariest thing he ever did, best decision of my life. So I transitioned. Instead of going from Fisk to Vanderbilt, I went from Fisk to Yale. So south to north, different kinds of institutions, different kinds of practices. There's a whole story there. But what I wanted to point out here is the gift that my mentor gave me in letting me create my own pathway instead of trying to get me to be another version of him. That was the biggest gift he could give me. And I think in the frame of the times that we live in right now, The pathways that were available 20, 30 years ago just don't exist in the same way. So that generosity of like mentoring, of allowing a person to like come into who they are going to be as a technical expert is one of the biggest, best gifts you can give. And I think it's also going to drive the kind of talent we have going forward. Yale was an interesting experience. There are all kinds of talks that I could give there. And I'm happy to answer questions about any of this. But ultimately, I think what came out for me from Yale, in addition to a technical expertise in understanding how blazars, supermassive black holes with relativistic jets that are 99.999% of the speed of light, generate particle acceleration that dwarfs anything we could do on this planet. We'll come back. In addition to that, there was also like for me, the sociological experiment of like, I'd gone to these institutions that were mission-driven. For me, in my case, it was historically black colleges. And then I went to Yale, and like the classroom was demographically vastly different. Like it just was vastly different. And I was blown away by this because there were people like colleagues, peers in my class, sitting right next to me, who were brilliant. Brilliant. My favorite story to tell about this is I had a friend who we both sat in all of our calculus classes together. We sat together. She had this beautiful penmanship. She wrote her notes in color. So when we were doing triple integrals, I am like struggling to be like, what is the limit, the upper limit on the third integral? And she's like, well, you know, if you write your equation like this, it will be very, and like, she just understood it. She didn't have to think about all the things that I had to think about. But when it came time for us to transition, say from bachelor's to master's, she didn't want to leave. No difference in talent or ability, just a difference in her perspective of what she wanted to be. So I think, you know, I was very blown away by like, well, why is it that the classroom is so different? So I spent a lot of time reading and thinking and processing and talking to people. The good thing about being at an institution like that was there was a lot of like other experts in vastly different areas that I could ask questions of. So I did, because as you'll recall, I have questions. So I wanted to know, why is the classroom like this? Like, why is it that like there's talent all across the world, and it's distributed independent of what we look like? Well, how does the classroom look like this? And more importantly, what can we do to expand it? Like, how can we just make it more possible for more people to experience these extreme resources? So I'll take a pause here for my story and just talk about my science, because I feel like it would be unfair for me to both not have slides and also not talk to you about science. So I will talk to you about science for a minute, and then we'll come back to the path. So supermassive black holes come in a variety of shapes and sizes. The ones that I study are 10 to the 6 to 10 to the 9, so 1 million to 1 billion times the mass of the sun. They sit at galaxy centers. Base fact, we believe now that all galaxies have supermassive black holes at their center. The question is how active that black hole is, that is to say, how much material is it accreting onto itself, and what the fraction of that luminosity is to basically the luminosity of the rest of the galaxy, right? So all galaxies have them. Every galaxy you see has one. We have one. It's really cool. M87, you should check it out. But there are a certain class of them that what we call active. That means that their accretion rate dwarfs anything we've ever really seen in other systems, and it produces so much light in the translation from accretion of material being heated and swirling onto a black hole that it dwarfs the light of the entire galaxy. So that's the first thing. They're just extremely bright. So people who study black holes, supermassive black holes in particular, tend to like shield out the rest of the galaxy. You can do that like actually physically, but also we do it just in terms of the wavelength of light we look at. So I generally throw out thermal light and look only at non-thermal sources, because that's what black holes are, driven by synchrotron radiation. Okay, so these supermassive black holes can be active or quiescent. I study the active ones, 10 to the 6, 10 to the 9 solar masses. Then in addition, some of these active ones have extremely bright luminosities that come from what we call a jet. It's a relativistic jet. So you've got your spinning black hole at the center of the galaxy. It's rotating on its poles. From those poles are these highly collimated streams of material, charged particles, traveling at 99.999% of the speed of light. The question is, how does nature do that? Like, what is the primary and dominant physical process that drives this extremely relativistic motion? So effectively, we're just trying to understand particle acceleration in space. Now, the trick is that there is no practical applied, we're not going to be able to reproduce this on the planet. I wish we could, but we cannot. But it's really just to understand how nature can do it so efficiently. So we know some baseline answers. One, it has to be magnetically driven. I say that because if you look at the spectral energy distribution of these sources, they are dominated by non-thermal synchrotron radiation, so we know it's got to be a magnetic field. But how the magnetic field is doing it? Is it doing it through reconnection, like the sun does? Does it do it through nozzling? So you're just twisting your magnetic fields? There are all these questions about how exactly you can get a magnetic field to take these particles that are moving roughly sonically across the accretion disk, swirling in, losing energy, falling onto the black hole, and some fraction of them is then being shot out relativistically at these jets. I am an observational astrophysicist, so the way that I do this is by looking at a multi-wavelength spectrum of light, from radio all the way up to gamma rays. So the thing with these jets is because they're moving this fast, and blazars in particular are pointed at our line of sight, so at the Earth, very far away, you're totally safe, at least from those. The light is actually, because it's relativistically traveling at you, it is superluminally beamed, so it looks like it's traveling faster than the speed of light. It's not. You can back it out. It's a geometric effect. Super cool. But that means that the time scale of variability for these sources is, depending on the wavelength, minutes, days, hours. So if you're trying to take a whole multi-wavelength spectrum from radio to gamma rays, and you've got a source that's varying on time scales of minutes, hours, days, then you need to be able to observe them basically simultaneously to say what is changing on the same time scales or not. So that is the crux of what my research was. I spent a lot of time using data sources from NASA, spaceborne, NSF, ground-based telescopes, to really try to figure out and get at this answer. For this particular audience, we did a lot of time series analysis. We did a lot of discrete correlation functions that were perilously close to undersampled, but they were not undersampled, trying to figure out how much we could pull from each wavelength of light and its correlation, and whether or not that correlation could tell us something about the fundamental physical process that drives this acceleration. So that was our research. Happy to answer questions about that too. There are some points in there, even in my little mini science lesson there, that are worth the conversation going forward. Number one, I used federal resources to do my research. It was NASA resources, NSF resources. I didn't use supercomputing capacities at Energy or anything like that, but I had colleagues who did, and all of that, when I was an assistant professor, was just in the ether. But what I learned later on in policymaking is that the budgets that are appropriated to align to the resources that I need are very connected to my ability to use these resources. So that's where we're going as a foreshadowing. Okay, so I'm at Yale. I'm looking at the fundamental processes of the universe, and also the sociological demographic experience in the classroom. And I decided that I wanted to address both. I wanted to both understand the universe a little bit better, and I also wanted to understand the classroom a little bit better. So I started to read about it and write about it and build programs that would help me understand and also help folks who are going through the experience also feel like they were seen and heard and understood for the situations that they were encountering. That work, it turns out, if you talk enough, people will ask you to keep talking. Who knew? So my field first started to ask me, okay, well, you keep talking about this. We hear you. What do you want to do about it? And I was like, well, thank you. I'm glad you asked. Let me just pull out these notes really quickly. And we talked about, what can the field do? How can we make an impression that will be structural in its intervention, that will help folks be able to move through, while also just, pursuing their loves with science and technology and statistics and whatever it is that, that people are interested in. Astronomy does this process called the decadal survey. Does anybody know this, decadal survey? Yeah, some fields do it. It's a National Academies driven process where the field comes together kind of like this, honestly, and decides what the priorities are for their work. So they write up in each area what they want to do, and that material is then sent to NASA, to NSF, and to help inform what their budgets should be. The reason I'm bringing this up is because I was asked on the front end, do you want to participate in the decadal process? We want to talk about state of the profession, et cetera. But parallel to that, they were talking about the big telescopes we were going to build and what the next space-based telescope we were going to build, et cetera. That information for us, we did the work and passed it on, but that went into the conversation around funding for NASA and NSF and energy, et cetera. At the time, I didn't really understand the connections, but we were having a chance to influence what the future of our field was going to be. And it wasn't clear as an assistant professor that that was a thing that we were doing. So I just want to throw that out there. We're coming back to that too. Ultimately, I finished my journey. I got my PhD, did my work, wrote my dissertation, did a postdoc, ended up as an assistant professor at Dartmouth. It was great. I loved it. My students were brilliant and amazing and creative and innovative in ways that you sort of hope for when you're dealing with students. I spent 3 years there, and it was lovely. And then I had the opportunity to start to think about science policy. And that's where my life really drastically changed. As you can see, I like new things. I like asking questions. And I like the opportunity to influence the future. So when folks started saying, well, you have these good ideas for the field, do you think they could be applied across disciplines, across science disciplines? And I was like, well, I think so. We should try. We should try. And that led me down a long road, which I won't belabor here. I'm happy to answer questions about it. But the long and the short of it was, it brought me into the White House Office of Science and Technology Policy. Long journey, short answer. That is where I learned where my technical ability can really service not only myself, but also my field and the nation. The connection between my specific deep interest in supermassive black holes and the resources that a field has to produce research, and then the ability to influence that, my mind was blown. So that's where I made the turn from academia to policymaking. And I highly recommend it. In a minute, I'm going to push real hard to encourage you to do the same thing. But ultimately, all the experiences I had up to this point led me to a moment that I think I would not have had any other way, right? I needed to have that initial spark that was I love science. Science is amazing. I want to do more of it. I needed to have the experiences in institutions where they were we just want you to be great. You figure out whatever it is you want to do. We want you to be great. Then I need to have the experiences where okay, let's turn it up a little bit. let's get going. And then I need the experiences of being all right, finish this thing up, right? I needed all those experiences, but I also needed to have time and space along the way for people to encourage me, to motivate me, to help direct me and wayfind, while also offering up different visions of the future. So my story is one story. It's one example. I'm happy to go into it, but there are themes that I think are much more universal that I want to encourage you to take with you. So going back to our notion of doing something, there are easy ways to do something, and I know that a lot of you in this room already are, right? Those are interpersonal things. I'll stop here and say my favorite quote from Ella Baker, who is a 1950s era civil rights icon. She said, if there is any philosophy, it's those that have walked a certain path should know something, should remember something that they can pass on, that someone else can use to walk the path a little better. It's a guiding principle in my life. You are at the pinnacle in many ways of your field, of your society, of your country, because of the investment made in you. So my ask when I say to do something is to figure out that thing that sparks you, that you really appreciated in your history and in your upbringing, and do that for someone else. If you want to get a little more into it, you can also do service at the local level. Is there a program or process that you can build and expand upon? If you want to get even more into it, have you thought about a campaign lately? Anybody? Campaign? Have you thought about public service? All these things can really be a part of going from a future that feels maybe a little overwhelming and intractable and that all the good answers have been solved and how do we make any more improvement to, oh my goodness, the future is fiction until we create it. Like, how are we going to come up with the next new thing so that the next frontier of science, technology, innovation builds in a really beautiful way on the things that have already happened, while recognizing that the whole pathway and process will be different from those coming before us. So maybe the last piece I'll say about public service, I mentioned that my research was NASA NSF based. And then I worked in this office where the decadal that I had helped with found its way on the other side, and they're having conversations not necessarily about the scientific merit of a particular request, but of the whole package and how that package fits in with what energy is trying to do, with what particle physics is trying to do, what these other fields, all of those things matter. Now, not every field does a decadal survey. It's this historical whatever, different fields do whatever they want. But there is often an opportunity, because it is federal resource, for you as technical experts to weigh in on what is happening, not just with your particular thing, but with the health of your field, and by that, the health of the nation. So I would encourage you, if you're interested or even have a half a question about it, to consider public service on a short term or a long term, on a local, state, federal level, because it will not only benefit the nation because you are the most well-resourced, curious, bright people, but also the entire nation, because you will reproduce better versions of yourself, and you're pretty rad. So I'll stop there and just encourage you to do something, and thank you so much for your time.
Thank you very much, Dr. Eisler. That was very inspiring.
Thank you.
We very much appreciate it. We have, we have time for some questions. There's a couple of folks in the back with some microphones who will be happy to bring them to you. Wait until you get a microphone before you ask your question, and when you do, be prepared to stand up, tell us who you are, where you work, and then your question. That would be great. I'm gonna start with one, if you don't mind.
Do it.
We spend a lot of time here thinking about communicating, and especially communicating for change, right?
Yeah.
There's a process that we've figured out, somebody's figured out, needs some change, and you have to explain what that change should be. You've probably had to communicate some fairly technical concepts to some people who may not have been quite prepared for them, shall we say. Policymakers, for example, politicians, senators, so forth. Tell us more about what are your strategies for helping to deal with that?
Yeah, it's a really good question. And honestly, that's one of the benefits, I think, of having worn so many hats before I got there, is that you realize that it is much more important for the person you're speaking to understand what you're saying than to be impressed with how technical it is. Because people can walk away blown away by the words and the jargon and not understand at all what it is you want them to do, which in the context of policy is not what you want. It's much more important to understand what the core messaging is that you want and the action around it that you're hoping for, and to make sure that point is communicated clearly and is understood. So I think it's a very relational thing.
Very good. Question from the audience. Who's got one for Dr. Eisler? Michael, right up down here front. Thank you, Kirsten.
Thank you. And thank you. I'm Michael Akerman. I'm a research software engineer at the biotechnology company Novanessus. This being the conference it is, you mentioned you are an observational astrophysicist. Could you comment on the technologies you used to deal with your data challenges as you went through your research?
Oh, data. So there's a huge, I'm going to answer that in two ways. One is that there's a huge conversation right now across the government about data standardization and how we can make data useful to people coming at it from different angles by making sure, say, for example, the metadata is consistent and there's a way to handle the data in a way that's consistent along different systems. It is a really tough process because, as you know, once you get attached to one way of doing it, when someone asks you to do it differently, havoc ensues. But for my specific research, it was really about, I'm not going to say the language I use because I don't want to be thrown out of here, but it was a different language. I don't know yet. We're still filling it out. So just to say, we did a lot of work in trying to like build the best process for a given wavelength, and then use that in the proximal wavelengths near it until we couldn't, right? So basically any ultraviolet through infrared light, we could approximately process the same way. So we tried to do that pretty consistently and make the error bars on that as small as we could. And then we moved into X-ray, which is a very different game, and had to figure out how to deal with trying to pull out the same quality of data with many fewer photons. And then when we got to gamma rays, it was a different game altogether, because even the detection, there's a ton of different ways. So like, even if the sort of federal context were able to answer it on like a broad scope, like the physics of how data is produced in the field that I was what I am in, makes it hard to like get super efficient.
Sure. Yeah. Thank you.
In the middle, right here.
Hi, I'm Kara Happy. I work at Promega in Madison, Wisconsin. So as you said before, life be lifin'.
Yes.
And as we all know, change is hard.
Yes.
So over the course of your life, what strategies have you developed for, when you find that resistance to change in those days where you just kind of get beat down, just kind of keep going and make that change actually happen?
I really appreciate that question. I really appreciate that question because I was having a conversation, I don't know if he's here, but I was having a conversation last night at dinner regarding my decision to leave academia and go into policy. And it's quote, that seemed like a boss move at the time, which I appreciated. But when I was going through it, it was terrifying, right? Because anyone who's been in academia knows that like there is a pathway. It has barbed wire on each side of it. And if you get too close to that barbed wire, it will cut you. Like, that's just facts. And so when I had made it, right? Like, I was at a very good institution. I was on the tenure track. Like, it was the field that I had chosen. Why would I leave? And it took me a long time to get to it. But for me personally, I just knew that, like, the impact that I wanted to have in the world, I wouldn't be able to do there. And what I view as broad set of skills that I have in things that like I do think about communication, and I do think about people, and I do think about like how people engage, in addition to thinking about technical questions about how to actually reduce data. Like I knew that I was never gonna get at all of that. So I had to sort of leap into something that was unknown and hope it worked out. But it took me a long time to think about. And I had to really be sure that I was doing it for me. And at the time that it was the right thing for me and that I was willing to handle like whatever came after it. And maybe just one more thing, because I want to make sure other people get to ask questions. But the other thing I think is that I had to make that decision at the time that I made it in order to be comfortable with it. So like I said, I did my master's, my PhD, then in my field we do postdocs, sometimes two, and then hopefully you get a faculty position. It was important for me to make it to get the faculty position so that I knew in my own head that I could do it. I feel like if I had stopped, personally, this is not a recommendation, but for me, if I had stopped short of that, I would have been worried about why I stopped. Whereas having gotten to the place that I said I wanted to go, I could be like, actually, I'm here, I see it, it's great, not for me. I felt more comfortable in it, but it certainly has not been like sunshine and rainbows every day, and I think to honor both the high points and the mountains and like the times you're like, yes, I did that, and also the times where it's like, I actually just don't know, and to be comfortable in both of those moments and not rush it is really important.
Other questions? There's actually, Kirsten, there's one right behind you. That's okay, that's in front of you, but that's close enough. No, go ahead. No, go ahead.
Thank you. Thank you for your nice presentation, first of all. Especially like the zero slide thing.
Cut my slides.
Myself is Dr. Moni Sharkar. Yeah. I am from US OPM. Yeah. And I also, we have a similar path. I am a faculty, assistant professor
Yes.
of Morgan State University, another SBCO.
Yeah.
Yeah, from there, currently I'm working for OPM.
Yeah.
So now question is for you, now you are, transition from academia to Fed.
Yep.
Now, where do you see the bridge between the research that you conducted there and the policy area that you are working now? That's one question. And the second one is, we are all here for Data Analytics Summit,
Yeah.
right? So what type of data you are, collected for your research,
Yeah.
for that particular research, and what research question you were trying to answer, and what type of data analytics tool you used in that research?
Y'all are trying to get me in trouble? Ah. I thought we were friends. God. Okay, so first question. There were a couple of ways that like my specific technical training helped in the job that I had at OSCP. The first is that there were literally random calls where it's like, okay, the president wants to talk about JWST. How big is a galaxy in like regular terms, right? You know, like, because 10 to the 6 doesn't resonate with people. I don't know why, but it doesn't. Meters, by the way. I have units.
Obviously.
Obviously, not an animal. Sorry. So anyway, there was the like literal like specific technical work. You know, there were times when Aura would come and they'd want to talk about like facilities usage, and we'd have conversations about what that meant for ground-based astronomers, for example. We'd have conversations with NASA about various things that came up. I don't want to like call up any particular things, but like there were actual, just like my actual field of study helps here. Broadly though, it is the knowledge of how science and technology training takes place, like where folks are when they're in a given period of their development, a postdoc versus a early career faculty member versus a graduate student, what transition points and tension points would look like. So one of the things I didn't say is one of the major policy efforts that I did when I was first coming to OSCP was around equity in STEM and how you could build a national strategy that like supported a more equitable science and technology ecosystem. So knowing many people, including myself, who have gone through these pathways can inform like, yeah, that sounds good on paper, but that just doesn't work in this field for these reasons. So some of it is lived experience and contextual, and then some of it is like the critical thinking and specificity of like, I know this feels very soft, but there is an actual answer here, and we have to get to it. So I think all of those pieces play into it. I still refuse to talk about data software.
I'm sorry, it's pronounced jump and
Jump.
sass. Just
Jump.
to be clear, yeah.
Where's the
There you
mic?
go.
No, like, but like, I'm not going to talk about my language. But, for example, in the ultraviolet through infrared, that set of wavelengths use basically CCDs to measure light. So it is easy. You have a ton of photons, and it's easy to do statistics on it. So we could run DCFs up and down, U to I, et cetera, et cetera. Once you move into radio, I said UV this way. So once you move into radio or X-ray, the technology changes quite a bit, and so like how much data you can get out of it matters, and the way that you're doing your analysis matters. And so when you see what we call spectral energy distribution, so when you see your SED, you have all your data points on it, but the uncertainties hold, this is true for everybody, a multitude of sins. And so figuring out how to truly compare the actual uncertainty on an X-ray data point versus a visible one was a huge part of the work that I did, and it constrained how much correlation I could say that there was, particularly in these very distant parts of the SED. When I was in graduate school, Fermi Gamma Ray Space Telescope was just coming out, and that was a revolution because it was allowing like minutes, hours, time scale variability at high energy, which was really hard to do. Chandra was the next closest thing in X-rays, and it could not do what Fermi did. And so it was amazing to have enough photons in the lower energy part of the spectrum where non-thermal synchrotron radiation was dominant, and then now the high energy portion of the SED where you had gamma rays peaking in like minute, day time scales to be able to actually do equivalent statistics. So that was the name of the game for the work when I was in it. I was talking to John earlier, and I was saying, like, if I were to do a video, if I had one slide, it actually would not be of my research. It would be of the Event Horizon Telescope research, which if you haven't seen that and you're interested in supermassive black holes, that is the rabbit hole to go down because it's effectively imaging the supermassive black hole at the center of our galaxy and M87, which is a nearby galaxy. So there's an incredible amount of physics. The technology and the data analysis actually around that is breathtaking and amazing. There's all kinds of physics we're going to learn.
All right. We have one right down here in the front.
So my name is Seth Jesse. I work at Valvoline from Lexington, Kentucky. And kind of bouncing off the question of dealing with the discomfort and turbulence of change. We all only so many get, so many opportunities in life. So kind of the question I have for you is what's kind of the discernment or the process that you undergo to generate chances to actually, make that change or make something happen?
Yeah, it's a good question. For me, it really is. I'm a verbal processor, and I'm an extrovert. And so those things work to my favor. Did you notice? You're laughing. Weird. Those things work to my favor. And I say them like explicitly because they are assets to me that are not like everybody doesn't like to be an extrovert. Everybody is not a verbal processor. And so there are privileges that I have from just those two characteristics that help me along because I, for example, feel like it's a good idea to ask questions. And so I often ask questions of literally anybody. Like we're talking, I'm just curious about what you're doing. And if you have an idea and I have an idea, then I'm like, can we do something along these lines? And so I think some part of it is just like being willing to say the uncertainty out loud, honestly. That was a skill that I feel like I had to pick up a lot, is like, it's okay to not know. It's also okay to ask for help. And that's actually where the most interesting, new thing came from. Because well, I don't know either. Do you want to try? Yeah, let's go, is how that worked. And I think the other thing, going back to like how I know, is I think the number of opportunities we have is vastly greater than the number of opportunities we think we have, right? And so like, I feel like and this is why I was saying the future is fiction until we create it, like I feel like there are just ways that what seems like it might be far-fetched or outside of the realm of the possible just needs like a little seed of like belief or hope. And it might turn into something. And I know that feels like hopey changey and all that stuff, but like I truly do believe that like there is so much more opportunity than we often give ourselves credit for. And then I got really used to just like both uncertainty and failing. I just got really used to being like, if I choose something and it doesn't work, that doesn't mean that I didn't work. There's something wrong with me as a person. It's just that thing didn't work, which is also something that I had to work like a lot on. So as long as I'm willing to like bear whatever the consequence of whatever wild hair that I am now chasing, I feel okay. And so far it's been all right. It's been all right.
Well, there's a couple right over here, Kirsten.
Hi, Shafi from Lamb Research.
Yeah.
It's a very personal question that I would like to ask you.
Sure.
So you talked about your mom, right?
Yeah.
So if you were in her shoes,
Yeah.
how would you inspire, a version of you, a future you,
Yeah.
in addition what she did to you?
Yeah. That's a good question.
Thank you.
That's a good question, because my mom is like the best. She's the best. So like asking me to like better her is very difficult. I feel like I'm going to start with what she did and then try to expand. I feel like the most powerful thing my mom did for me was to make baseline that I could do anything. That was the baseline. And it didn't really matter what it was, and it didn't matter like how committed to it I was. I could do it. If I wanted to, I could do it. And that's what I would carry on and extend. And in fact, when I talk to young people about this, a lot of what I say is that like it actually doesn't matter. This is going to be controversial because it kind of does, but like it doesn't matter who you are. You can be anything you want to be. Now, the barriers and things that surround you may be different, but you have the innate potential to be anything you want. So I often try to convince young people that that is the case, and also that there are many opportunities, right? That there are many options and failure is one of them, and that's okay. You know, they talk about, many of you come from industry, they talk about failing fast and often, right? You just get it out of the way, you know, and that there's no perfection. My hope for the future, though, as the landscape changes, is that there's more space around the fact that, like, we can train folks with the skills they need to be technical experts. We don't actually know what their job is going to be anymore, and they're not going to stay in it for 30 years. So, like, figuring out a way to also explain to them that, like, the messiness is now just, like, innate in the system, and that it's okay, and you can figure out your way through. So I tend to talk to them about stuff like that.
Before we get to the last one from the audience, I'm going to take the moderator's privilege and
Okay.
ask. I hope this will be a serious question from the audience, because
Okay.
mine is a little bit more frivolous.
Okay.
You mentioned Interstellar. First of all, how realistic was that? And if you had to pick one or two movies that, you know, if we wanted to learn something but in a more entertaining way, or in an entertaining way, what would you suggest?
So many to be friendly, and then you keep asking me all these controversial questions. Okay, so I loved Interstellar for a number of reasons. It was actually incredibly accurate until it was completely not accurate at all.
Right up until...
And I feel like we all know when that happened.
Felt the same way about Gravity, by the way, just some saying.
Yes, listen. And so I watched Interstellar because Kip Thorne, who probably some of you in the room know, like, Kip Thorne did a ton of work on the modeling in that movie. And one of the things they like to say is, like, it's the most accurate modeling of a supermassive black hole ever, blah, blah, blah. The trick to that is that it's because he did it from the vantage point of, like, where you would be in that ship, which in astrophysics we never do. Like, we don't model things from, 30 parsecs from the, right? It's still amazing, and when I watched it, I will just tell you, because I am a nerd, when I watched it, I had this, just one silent little tear that was just like, Gargantua! Like, it was just, because it was amazing, like, that they would take the time to really try to render these very complex physical concepts in real life. I just thought that was amazing. What else would I recommend? Honestly, I like a lot of the, like, SciComm stuff that's, like, the revision of things that have happened, like updates to, like, Cosmos series. I like a lot of YouTube around this. You have to be careful, obviously. But I like the new SciComm that's coming out around this stuff, where it's like, how do you, like, get at these complex questions of, like, special relativity? How do you get at general relativity? How do you think about these things in a way that's very playful? So, like, a lot of mine are, like, millennial or Gen Z folks that are just like, this is how you do it, and it's amazing, and an art, and they should get Pulitzers or whatever for it.
Very good.
Truly.
All right, thank you. Go ahead.
Jonathan Schisler, I'm assistant professor at UNC Chapel Hill.
Nice.
The library card, thank you
Yeah.
for sharing that.
Yeah.
That really hit a nerve with me. I found my book.
Yeah?
So keep looking.
Okay.
Keep looking. But I was waiting. Was there another library card moment
Yeah.
that you experienced when you decided to make that transition? Or was it sharing or through someone else's eyes that same moment that made you say, this is the path, my new path?
Do you mean transitioning to policy?
Yeah.
Yes and no. It was like a very, like, both clear and unclear revelation for me. On the one hand, it was like, I really truly love teaching astronomy, particularly Astro 101, because, like, you could just blow people's minds, and it's amazing. But it was never going to answer that. Remember, that second question I had in graduate school was, like, not only the technical, like, how does it work, but, like, how do these people get into the room? And I could see very clearly that I was never going to be able to answer that question in a way you might recognize that, like, was acknowledged by my institution or gave me time and space to do that work. So it wasn't the same in terms of, like, oh my gosh, this is all clear to me, particularly because, quite frankly, I didn't understand what science policy was until I really got into it. But then once I got into it, I was like, oh, this is actually it. This is actually it, because I still get to help with the technical. I still can collaborate with people if I really wanted to. And I get to answer the question about, like, how do we make sure that as a nation we're doing the best for our next generation? So less book, but more like feeling, passion.
Well, thank you so much. I hope you all have been as inspired as I have been. Let's thank her one more time. Thank you, Dr. Isaac.